A 15-year-old female patient is brought to the clinic to evaluate primary amenorrhea. The patient's breast development is consistent with Tanner stage 1, and her pubic hair is consistent with Tanner stage 3. The patient has a blind vaginal pouch, and imaging reveals the absence of a uterus and fallopian tubes. Bilateral epididymis and vas deferens are present, and testes are seen bilaterally within the inguinal canal. Karyotype analysis indicates 46XY. Which of the following underlying mechanisms is most likely responsible for this patient's condition? Now, this patient has internal male genitalia, and we know that from the question stem telling us that she has bilateral epididymis, vas deferens, as well as testes, which are all male internal genital structures. And she also has external female genitalia. From the question stem, it tells us that she has a blind vaginal pouch. Her karyotype analysis revealed that she has the 46XY chromosome. Now let's go over a map that is going to help us um, help us know what is going on with this patient. Now, in an early embryo, the undifferentiated gonad can differentiate into the testes or the ovary, depending on if there is an SRY gene present. SRY gene is going to be found only on the Y chromosome. Now, this patient had a XY chromosome, and because she has testes, we know that she must have had the SRY gene. So now we're going to be focusing on the right part of this map. So she has the XY chromosome and she has testes. Now, testes are going to contain the Sertoli cells as well as the Leydig cells. Remember that Leydig cells are going to be producing testosterone. Now, testosterone is going to be responsible for developing the male internal genitalia. So if someone has production of testosterone from the Leydig cells, then this is going to lead to Wolffian duct proliferation, and then this is going to develop the male internal genitalia. So the epididymis, vas deferens, and the seminal vesicle. These are all examples of male internal genitalia, and this is what our patient had in the question stem. Now, in order to develop the male external genitalia, we need the conversion of testosterone into dihydrotestosterone. And this is going to be done by the enzyme 5-alpha reductase. Now, dihydrotestosterone is going to be a much more potent androgen than testosterone because it is going to bind to the androgen receptors more tightly. So it is going to have much more stronger effects. And as a result, DHT is needed in order to produce male external genitalia. So because our patient did not have male external genitalia, we can safely conclude that she did not have the enzyme 5-alpha reductase. So this was the enzyme that was missing in her because she does not have male external genitalia. Remember from the question stem that she has a blind vaginal pouch. And this is because in the testes we also have the Sertoli cells, which produce the hormone anti-Mullerian hormone. And this hormone results in Mullerian duct regression. Mullerian duct is responsible for producing the uterus, the fallopian tubes, the cervix, and the upper part of vagina. So because she does not have male external genitalia, she started developing female external genitalia, but because the Sertoli cells in her testes have produced the anti-Müllerian hormone, which led to Müllerian duct regression, she does not have the upper part of vagina, and so that is why she has a blind pouch. So as you can see from this picture, this is going to be an example of a blind vagina where there's not going to be an opening into the vagina. So to answer the question, the patient does not have the enzyme 5-alpha reductase because she was not able to produce a male external genitalia. And so the answer is going to be answer choice A. There's an absent conversion of testosterone to dihydrotestosterone because dihydrotestosterone is responsible for producing male external genitalia.